Hi, I'm Lisa, and this week on NASA Now, we'll meet the lead flight operations engineer for the experimental X-48B aircraft to find out about green aviation. This new technology will allow future aircraft to have a minimal impact on the environment. But before we get to that, let's find out what else is happening at NASA now. NASA researchers determined that climate change has caused the Earth's largest lakes to warm during the past 25 years. Satellite data from 167 large lakes worldwide showed a warming trend of almost ½ degree Celsius per decade. In other news, NASA's Stratospheric Observatory for Infrared Astronomy, otherwise known as SOFIA, completed the first of 3 scientific flights recently. The Airborne Observatory is an international collaboration between NASA and the German Aerospace Center. SOFIA allows researchers to better understand a wide range of astronomical phenomena, including how stars and planets are born and how supermassive black holes feed and grow. Now, let's take a look back at the past.
May 27, 1931, Langley Field in Virginia completed the world's first full-scale wind tunnel. This amazing facility allowed researchers to test full-size models without risking the life of a pilot or destroying the test aircraft. 78 years later, Boeing was last to use it when testing the X-48C, just before the facility was shut down in September of 2009.
When it comes to innovation and development, NASA is second to none. Here to tell us more about the environmentally friendly X-48B aircraft is Gary Costantino, lead flight operations engineer at NASA's Dryden Flight Research Center.
My name is Gary Costantino. I'm at Dryden Flight Research Center. I'm within the Flight Operations Directorate at Dryden, and I'm a lead flight operations engineer. The X-48B is a subscale representation of what could someday be a very, very large airplane, more than a 200-foot wingspan, weighing almost 1 million pounds. What we have with the X-48B is an 8.5% scale of that, which brings it down to about a 21-foot wingspan, and it weighs about 525 pounds. This is a hybrid wing body. It doesn't really have a distinct fuselage, nor is it just a pure flying wing, but it's sort of a combination of those two, and it's a very interesting aerodynamic shape for us to be studying. The large center body does a lot of aerodynamic lifting for us in addition to the wings, and this large body, while contributing to lift, also houses a lot of volume for whatever cargo or fuels you might want to carry. If you look at a cut through a wing, actually at any section along this particular shape, but particularly through the wing out here, what you'll see is a gently curving surface that is blunt at the leading edge, grows in thickness, and then tapers down to a very thin trailing edge. The curvature is more accentuated on the top than it is on the bottom. And what that does is, as the airplane flies through the air, the free stream coming in at the wing, in order to get around that upper surface curvature, it has to accelerate. And Bernoulli's principle states that if the velocity of the air goes up, its pressure drops. And that creates a net differential in pressure, which translates into an upward force, which we call lift. Green aviation to me is just like all the other green initiatives where we want to reduce the impact of our activities on the environment. If you notice, the engines are on the top, and the large surface area of the upper surface of the airplane shields folks on the ground from the noise that the engines produce. The engines themselves are getting more and more efficient every day, larger and larger turbofan engines with high bypass ratios. They pollute less and less all the time. And just the shape of it is very aerodynamically efficient, so it inherently will burn less fuel for the amount of cargo carried per distance. use the same type of test pilot that any test aircraft would fly with, but we put him on the ground in a control station. He has a cockpit very much like he would have if he were actually sitting in the airplane. He has a camera looking out the window that he can see the same view that he would see if he was actually sitting in the airplane. And that's just the way we do flight tests at this particular scale. The most valuable sensor is what we call the IMU, or Inertial Measurement Unit. And that's basically a box riding on the airplane, sensing all the turns and G-forces that the airplane's going through. And that's really how the research is done, is by comparing the onboard data to what the ground station sent up in the form of pilot commands. And making sense of those is how we determine how well the airplane is flying, how stable it is, and what adjustments, if any, we need to make.
Did you know NASA has recently awarded 3 contracts for studies designed to develop advanced concepts for airliners that will fly with less noise, cleaner exhaust, and lower fuel consumption? Well, now you know.
Today we learned NASA is working to develop a new generation of aircraft incorporating green technology. Now it's your turn. Check out this activity on the NASA Explorer School's virtual campus.
This week's activity challenges you to analyze design decisions that affect fuel efficiency. Make 2 calculations on an aircraft's thrust and drag, one with the vertical tail on and one with the vertical tail off. You'll be surprised at the results.
Well, that's it for NASA Now. Join us next week when we'll take a look at solar panels, how they work, and why they play such a vital role on the ground and in space. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.